You ever watch a fireworks show and just wonder? How do they get those incredible bright reds and greens? Well, it's not magic, it's pure chemistry. And hiding inside all that light is a kind of secret code, a fingerprint that tells you exactly what's burning up there.
So let's just jump right into this. What if the phone you're probably holding right now, the one you use for everything, could actually decode those chemical secrets? What if your phone could basically become a portable chem lab?
See, when you heat up an element in a flame, the color you see isn't just for looks. It's a clue. A very specific, super reliable clue to its identity.
Now, the science behind all this has a name: flame photometry. It sounds complicated, but it's really just a powerful way for scientists to figure out how much of a metal is in something just by looking at the light it gives off when it burns. We're literally reading light to understand chemistry. And what's so cool is how unique these signatures are. It's really like an atomic fingerprint. Sodium, it's always going to burn with that classic golden yellow color. Potassium gives you this distinct violet, and lithium, a beautiful crimson red. Every single one has its own color code, no exceptions. Okay, so if the idea is that straightforward, why isn't every science class on the planet doing this? Well, that leads us right to the big roadblock. It comes down to money. The professional gear, the actual flame photometers that do this with incredible precision, they are just crazy expensive. And that price tag puts up a huge wall, stopping so many schools and labs, especially in developing countries, from getting their hands on this tech. But what if you could just sidestep that cost completely? This is where a really clever solution comes into the picture. A solution that mixes basic chemistry with the tech we all have in our pockets. This quote gets right to the heart of it. It's from the MPhil thesis of Muhammad Saleem Khan at the University of Malakand. His whole goal was to build a flame photometer from scratch, using cheap, easy-to-find parts, and make this powerful science accessible to pretty much anyone. So how'd he pull it off? Let's break down the build. First up, he needed to get the sample into the flame. For that, he grabbed a standard clinical nebulizer. Yeah, the same kind you use for breathing treatments, to turn his liquid sample into a superfine mist. And what about the flame? No fancy lab-grade fuel here. Just a regular old canister of liquid petroleum gas, or LPG, the same stuff you'd use on a camping trip. Now, the real core of this whole thing is a custom-built premix chamber. This is where the magic happens. That fine mist of the sample gets mixed really well with the LPG fuel right before it hits the burner and lights up. To get a good reading, you absolutely cannot have any other light messing with your flame. The solution? Simple but brilliant. A black metal box to act as a shield, making sure the only light being analyzed is from the flame itself.
And finally, the detector. The most high-tech, expensive piece of a normal photometer got replaced by, you guessed it, a Samsung Galaxy smartphone. The camera becomes the instrument's eye, all set to capture that colored flame.
So let's walk through the whole process. The sample becomes a mist. It mixes with the fuel and it's ignited. The smartphone takes a picture of the flame. Then, a simple app on the phone analyzes that picture and breaks the color down into its red, green, and blue, or RGB values. It's just such an elegant and cheap system, from start to finish. But how do you actually turn a pretty color into cold, hard data? This is the moment the smartphone stops being just a camera and becomes a legitimate scientific tool.
And this is the real game changer. It's the leap from just describing something to actually measuring it. Our eyes see golden yellow. Okay, that's an observation. But the phone, it sees precise numerical data, a red value of 225, a green of 255, and a blue of 155. Now that is a measurement. And with that, you can do some serious science.
So, the million-dollar question, did it work? Can a homemade gadget like this actually give you reliable scientific results? Well, the data really tells the story here. All right, so when they tested sodium, they saw a really clear pattern. The more sodium they put in the sample, the more the color of the flame changed, shifting from a bright lemon yellow to a much deeper orange yellow. You could see it with your own eyes. And the phone's data backed it up with hard numbers. Just look at this. The red value consistently goes down as the sodium concentration goes up. It's a clear, predictable trend, which proves the device is accurately tracking that change. And they had the same success with potassium. As they upped the concentration, the flame got deeper, shifting from a lighter electric violet to a more intense neon violet. And check it out, the data for potassium shows the exact same pattern, a steady drop in the red value as the concentration increases. This was huge because it proved the device wasn't just a one-trick pony. It could reliably measure different elements.
What we're looking at here is more than just a cool school project. This is pointing toward a future where science is way more accessible, way more democratic.
And here it is, the number that just changes everything. When they compared this homemade setup to a standard commercial instrument, it achieved 93% accuracy. That is incredible. It's proof that frugal science doesn't have to mean you're sacrificing quality.
Which really leaves us with a fascinating question to chew on. This project turned a phone into a spectrometer. So what other super expensive lab tools are just sitting there waiting for someone to reinvent them with the powerful tech we already carry around every single day? The possibilities, they're just amazing to think about.